What is up, my awesome tech family? Today, we're diving into something that's going to blow your mind: memory management in modern computers. Let me tell you something crazy. Right now, your computer is juggling hundreds of programs at once. Your RAM is only 16 gigabytes, but somehow you've got 50 Chrome tabs, Discord, Spotify, and 3 different games running. This is where virtual memory comes in, and it's absolutely insane. Imagine you're the manager of the biggest library in the world. You've got 2 spaces. A small but super fast reading room, this is your RAM. A massive but slower storage room, this is your hard drive/SSD. The genius part? When someone needs a book, you don't keep all the books in the reading room. You only bring in the ones people are actually reading right now. When someone needs a different book, you swap it with one that nobody's currently reading. This is exactly how your computer handles memory. It's called virtual memory, and it's like having a magic expandable RAM. Here's how it works. Your computer breaks everything into pages, like pages in a book. When a program needs memory, the CPU is like, "Yo, let me check if we've got that page in RAM." If it's there, awesome. That's a page hit and everything's super fast. But what if it's not in RAM? This is where the real magic happens. The CPU is like, "No problem, fam, let me grab that from the hard drive." This is called a page fault, but don't worry, it's totally normal. Now, here's where it gets wild. Your computer keeps track of every single page using something called a page table. Think of it like the library's catalog system, but way more complex. Each entry tells your CPU where the page is, RAM or disk, whether it's been modified, when it was last used, whether the program can read or write to it. But wait, there's more. Modern computers use something called TLB, Translation Look-Aside Buffer. It's like having a super smart assistant who remembers where all the popular books are. Instead of checking the whole catalog, they just know. The really crazy part? Your computer is doing this millions of times every second. Every time you click something, open a program, or even move your mouse, this whole system is working. Let's talk about some mind-blowing features. Memory protection: programs can't mess with each other's memory. It's like having security guards for each book. Demand paging: only loading what you actually need. Why bring the whole encyclopedia when you only need one page? Page replacement algorithms: your computer is smart enough to know which pages to keep and which to send back to storage. Here's why this is actually important. You can run way more programs than your RAM should allow. Your computer stays stable even when memory is tight. Programs don't need to worry about where in memory they're actually running. Different programs can't interfere with each other. But sometimes things get spicy. When your computer needs to swap pages too often, we call it thrashing. It's like if the librarian is spending all their time running between rooms instead of actually helping people read. To prevent thrashing, modern computers use some genius techniques. Working set model: keeping track of which pages a program actually needs. Page frame allocation: making sure each program gets its fair share of RAM. Priority-based page replacement: important stuff stays in RAM longer. The future of virtual memory is even crazier. Non-volatile memory: combining the speed of RAM with the permanence of storage. Machine learning-based page prediction: your computer might know what you need before you do. Advanced compression techniques: fitting more data in the same space. And get this, some systems are now using multiple levels of virtual memory. It's like having a whole chain of reading rooms, each with different speeds and sizes. When your computer runs out of virtual memory, that's when you see the famous out-of-memory error. But thanks to modern memory management, this happens way less often than it used to. Want to optimize your virtual memory? Here are some pro tips. Keep some free space on your SSD/hard drive. Don't disable the page file, trust me on this one. Consider adding more RAM if you're constantly hitting high memory usage. Close those 50 Chrome tabs you're not actually using. This is why SSDs made such a huge difference. When your computer needs to swap pages, an SSD can do it way faster than an old hard drive. Remember when we had to manually manage memory in MS-DOS? Now our computers handle terabytes of virtual memory without us even thinking about it. And that's the incredible world of virtual memory. Next time your computer smoothly switches between huge applications, you'll know the amazing system making it all possible. Want to learn more about computer memory? We could talk about cache hierarchies and how they make your CPU blazing fast. NUMA architectures in multiprocessor systems. Memory compression techniques. The future of persistent memory. Let me know what topics you want to hear about next. Until then, keep your memory virtual and your systems optimized.